Hi everyone. Today we're going to talk about question 3 on the June 2025 Earth and Space Science Regents exam. So let's get started. So, as always, underline or highlight any unknown words, word meanings, context clues, or important details given to you, relationships between things, and circle any task verbs that are given to you to answer the question. So, let's get started. The model below represents the orbits of celestial bodies around our sun. I highlighted model because this seems to be talking about this model right here. And what is this model about? Orbits of celestial bodies around our sun. So I highlighted that because it's a relationship or it's giving me context clues. The inset model, I'm highlighting that because now it's talking about looks like it's talking about the inset model. And what is this about? Shows some information about the region of the solar system inside the orbit of Jupiter. So I highlighted this portion because it gives me a context clue on what this model is about, and this gives me a context clue about what the whole model is about. Okay. I also highlighted Jupiter here because it's talking about Jupiter. It's a solar system model. I highlighted that, gives me a context clue. Instead model, I highlighted here because it talks about it here, and Jupiter here again. So when I need to look for information, I know to look here just in case. So those are the main parts I should look at. Now, number 3, the table below shows the eccentricity of the orbits of Mercury and Venus around the sun. So I highlighted the table because it's talking about the table. And what is it about? The eccentricity of the orbits of Mercury and Venus around the sun. I highlighted these things as well, these words, because I found it in the question. Place a check mark in the boxes to indicate the two statements that are correctly predicted by Kepler's laws. Circle the verbs that are given to you to tell you what to do in this question. So I need to place a check mark in these boxes, and I need to indicate two statements that are correctly predicted by Kepler's laws. So I highlighted Kepler's laws. I need to talk about the Kepler's laws, which I need background information on. Okay, so first thing I should do, go to the reference table. And I see that on page 2, there's information on the solar system objects. I look there and I see there's a lot of information on the sun, Mercury, Venus. There's eccentricity here, but I also see the eccentricity here. So that doesn't really help me out. But in case they didn't give me these numbers, I know I could look back here. Eventually, once you look at all the, keep practicing at looking at the reference table, it will be really fast for you to find any information that are not given to you and relate that information. Okay, so now that means I need some background knowledge. There's not a lot of information given to me. So let's talk about the background knowledge. So Kepler's first law, which is the law of ellipses, talks about all planets actually moving in an ellipse, not a perfect circle, but an ellipse is kind of a stretched out circle. The amount of stretching of the orbit is called the eccentricity. A small eccentricity, such as 0.001, means that the orbit of the planet around the sun or a star is a perfect circle or close to a perfect circle, sorry. And the larger the eccentricity is, such as 0.311, means that the orbit is actually more elliptical or more oval shaped. And if we compare the eccentricities, we can tell which planet's orbit is more stretched out. So a planet's orbit may be less elliptical, meaning less stretched out, or more elliptical, more oval shaped, or more stretched out. And the eccentricity, which is the number, gives me that information. Kepler's second law is the law of equal areas. It tells me that planets do not move at the same speed the whole way around the sun. The sun is actually not in the center of the orbit of planets. It's kind of towards the side a little bit. And so, because of this situation, planets, when they move around the sun, their speed actually changes throughout. They actually move faster when they're closer to the sun because the sun's gravity helps pull it around the orbit. So, it's faster here. But they're also slower when they're farther away from the sun because the sun's gravity doesn't help it out as much. It moves a little slower here. And this is called the law of equal areas because the planet sweeps out equal areas of space in equal amounts of time and moves at different speeds around the sun. But because of the shape of the orbit. Eventually what happens is the area that it's taking up here is it should be the equal should be equal to the area that it's taking up here. So it should sweep equal areas of space in the same amount of time. Even if it's moving faster around the sun over here, this area should be the same as this area, regardless of whether the speed of the sun is slow. Oh my gosh, the planet around the sun is slower or faster. Finally, Kepler's third law is the law of periods. The orbital period is the time it takes a planet to complete one orbit around the sun. And each planet has different amounts of time it takes to go around the sun. That's the orbital period. And planets that are normally farther away from the sun take longer to orbit, go around the sun. And planets that are closer to the sun actually take less amount of time. So you can see Mercury takes only 88 days to go around the sun, but Neptune can take 165 years to do that. And what are some important things we should remember about the Kepler's laws? Kepler's laws do not say planets move at a constant speed. Planets, when they move around the sun or any star, they're elliptical. Their orbits are elliptical, so sometimes they'll be move faster closer to the sun and slower farther away. The speed of the planet does not depend on its mass. Some planets can be very massive but move very slowly because they're farther away from the sun. The eccentricity, or the amount of stretching of an orbit, does not depend on a planet's moons. The moons that a planet has nothing to do with the shape of its orbit or how far it's stretched out. Finally, when looking at the eccentricity, which is the number given that helps us figure out how stretched the orbit is, the higher the number, the more oval shaped the orbit is. So Saturn would have a high eccentricity versus Mercury should have a low eccentricity compared to it. This isn't really that accurate of a diagram, but it really depends on how elliptical the orbit of a planet is. So let's go back to the question. This makes the answer this one and this one. So you should place a check mark there. Why? Because first off, Venus orbits the sun at a constant speed. That can't be it because planets don't move at a constant speed around the sun. They are sometimes slower and sometimes faster, depending on how close they are to the sun. Mercury travels faster in its orbit when it is closer to the sun. That should be correct because planets move faster when they're closer to the sun or the star they're orbiting. Venus's orbit is less elliptical than Mercury's orbit. They're giving me this information. It looks like Venus's orbit has a lower eccentricity than Mercury, which is the number given to me to tell me how stretched out the orbit is. Elliptical is the shape, meaning how oval like the orbit is. So the lower the eccentricity, the less elliptical it should be. The higher the eccentricity, the more elliptical or oval shaped it should be. So Venus's orbit does seem like it's less elliptical than Mercury's orbit. Once again, this is not an accurate diagram, just being used as an example. The orbital speeds of both planets are affected by their masses. No, the speed of a planet is not impacted by its mass. Unlike Venus, the eccentricity of Mercury's orbit prevents Mercury from having a moon. Remember, the moon or any planet's moons have nothing to do with the planet's orbit or eccentricity, so that can't be it. And I only need two statements, so I'm going to check off this and this. So in the next video, we're going to talk about question 4. That's it.